Problem 5. The following foreign adoptions in the United States occurred during these particular years, 2006 and 2010. In China, Ethiopia, and Russia. And here are the numbers of foreign adoptions. Choose one adoption at random from this chart. What is the probability that it was from Ethiopia, given, that symbol means given that it was from 2010? There are two ways we can do this. One way with a formula and the other intuitively is in the table. I'll show the intuitive approach first over here, and then we'll use the formula and see if we get the same. My first step, though, is to add all the rows, add all the columns. So let's add these. So we have, what's that? 9, 7, 8, 2. And then we have 3, 3, 1, 6. And then we have 5, 0, 4, 8. Okay, and if I add, let me just use this calculator so it'll be a little quicker. 9, 7, 8, 2 plus 3, 3, 1, 6 plus 5, 0, 4, 8. 18146. And when I add the columns and sum the grand total, I should get the same, right? So let's see, 6401 plus 707 plus 3818, 10926, and 3381 plus 2609 plus 1230, 7220. And when I sum those, 10926 plus 7220, 18146. So that's good. Okay. So this is conditional probability. This is saying, what is the probability that the adoption is from Ethiopia, given that we know this has already occurred. We know the adoption was from 2010. So we know the adoption is one of these, given it was from 2010. I know it's one of these. It can't be from 2006 because given that it was from 2010. So I'm not considering any of these 10,926. I'm only considering these 7220. That's my sample space. That's my denominator. Out of those 7,220, out of these 7,220, how many of them were from Ethiopia? What's the probability were from Ethiopia? Is the number from Ethiopia, which is, let's do that in a different color, which are these people, 2609. So that probability is 2609 out of these 7,220 people. Let's say you don't like that approach. Let's say you want to use the formula. I look at my formula sheet. I'm actually in the right place. Chapter 4, conditional probability here. Probability of B given A is the probability of A and B divided by the probability of A. So let's write that. Probability of B given A is the probability of A and B divided by the probability of A. If I was to map that to this situation here, it would be the probability of 2010 and Ethiopia divided by the probability of the event that's already occurred, divided by the probability of 2010. So to calculate this probability now, let's write this. The probability that this adoption came in 2010 and from Ethiopia, that's the intersection of the two, 2010 and Ethiopia. Now this is really 2609 out of 18146, right? So I'll be specific. right? The probability that you picked some random adoption from 2010 and Ethiopia, there's 2,609 of them out of the grand total, 18,146. And the probability this adoption came in 2010, there's 7,220 of those out of the big total, 18146. And what we see here is these are both divided by the same denominator, so that can cancel, and we're left with 2209 over 18146. Oh, ooh, oh jeez. I did a serious double take right there. Divided by 7220. And that's the exact same probability we got intuitively. We get the same probability using a formula.